Assalamu alaikum students, hope you guys are fine and doing well. This is Shamsa Jabeen. Today we are doing Cambridge IGCSE Past Paper 4 Extended Theory 1 and the code is 062541 Variant 1 May June 2025. In this video we will do question number 5 of this paper. So not this is 4, yes this is 5. So let's start with the question. A ray of light is incident on the film. Film. Figure 5 show a magnified image of a small part of the film and the ray of light is refracted, right? This light will refract as it enters the film. So the refractive index of the film is 1.28. I am just highlighting the data that is given, n equals to 1.28, right? Okay, define this refractive index in terms of speed of light. So there basically we need to find out the formula that we have to write the formula that relates refractive index with speed of light, right? And it contains how many marks? 1 mark. So we just give that specific formula. We know that the refractive index equals to speed of light in air divided by speed of light in vacuum. Sorry, not vacuum. Here we have the material, medium is soap. So we will write speed of light in soap film. So just write this formula, you will get the marks. Okay, now let's read the next question. Show that the angle of one more thing, we can also write speed of light in the short form. I will tell you, speed of light in air is mostly written as c, and speed of light in vacuum we can say v in soap. Sorry, not vacuum, speed of light in any medium we write with v and with the script light soap, air, not so what, air, water, whatever you want to write here, right? This is the short form, but it's better if you write the full explanation with the formula. Okay, now move to the question number B, 5b, first part. Show that the angle of refraction, we know that our ray will refract, right? It will enter in the medium. Okay, angle of refraction as the light enters the soap film is approximately 4.3. So basically here we know with two informations we need to find out the angle of refraction must be 43. So let's write the formula that relates the refractive index n, because we just have two informations. We have the information of refractive index n and we know the angle, right? Now here the thing that is important is we need to find out the formula that relates the refractive index with initial angle, incident angle and the refractive angle, right? Because we want refractive angle. So I am first just writing the angle and then we will discuss how we will substitute the values. N equals to sine I divided by sine R. What is I? I is the incident angle, and what is R? It is the refractive angle. Okay, now students, this point is very important, that how we will find out the incident angle. So I am making the space, some space, this one. Okay, here we know that this angle is 30. So what you guys, wait, this angle is 30, right? So what you guys think, is it an incident angle? Take time and think about, is it an incident angle? No, it's not an incident angle. How we will find then, if it's not an incident angle, how we will find it? just by drawing the normal. Incident angle will always be a normal to the incident light. This is incident angle, right? So I am removing this one. So this is incident angle, and how this I will be calculated. This is incident, and how it is calculated. It is calculated by 90, because this whole angle is the angle with the surface is 90 degree, right? So 90 minus 30 will give you incident angle. So incident angle equals to 90 minus 30, it is 60 degrees, right? And then we will find the refractive angle. Just put the values within the question, within the formula, and tell me what you guys get, right? Everyone do it by yourself and then cross it with the video that you are getting the same answer or not. So everyone start doing it. 1.28, the n value equals to sine I is 60 divided by sine r. Just cos multiply it, you get sine r equals to sine 60 will give you okay, you can solve it. Sine 60, wait, I write here sine r equals to sine 60 divided by 1.28, and then r equals to sine inverse of this whole answer, sine 60 divided by 1.28. So here you get the refracted angle is r equals to 42.577. So it is 43, right? So what answer you are getting? You are getting almost 43 degrees, right? And this is what we need to show. I hope you guys also get the same answer. Before moving to the next question, I make some space by removing it. Okay. So in this question, it takes 2 marks. 43 answer we get, but the important thing is we are using the right formula. Oh, sorry. Important thing is we are using the right formula and we are using the right angle, right? These 2 points will give you the marks. Okay. Well, now move to the question number. Its next part, question number B part 2. Figure 5.1, carefully draw the refracted light rays in the soap film and label the angle of refraction. Okay, so this one is again contains 2 marks, right? So let's start with the different color. Yes. Okay. It again contains 2 marks, so we need to show 2 solid answers. So first one is always before drawing the any incident light or the refracted light, it's compulsory to draw the normal with the surface. And we know that the angle is 43, so it is clear that our incident light must bend towards the normal. This is 60, So if this is the straight line, if I draw this straight line, this is the straight line, which is not the refracted line, right? For the refracted line, it must bend towards the normal. So this is the refracted line and the angle is 43 degrees. This is refracted angle, right? So in this one, what are the two compulsory things? You properly write the normal and you guys properly show the refracted angle, refracted ray and the refracted angle, right? So this is the right picture to give the answer. Okay, now move to the C part. The ray of light is monochromatic, red light, right, with the wavelength 680 nanometers in air. Okay, define monochromatic. What is monochromatic? And it contains 1 mark, so how we will explain it? Just a single code word, and that code word is monochromatic light is that light which has single frequency. Light with single frequency is known as monochromatic light. Right? Okay. Now the next question is calculate the frequency of light. So here we need to find out the frequency. So we will use the formula V equals to F times lambda. Lambda is given, wavelength is given. This is our wavelength, right? And here we need F equals to V by lambda. V is, I will explain both the terms. V is basically the speed of light in air, right? Or you can say the its value is 3 into 10 raised to the power 8 meters per second. It is basically the monochromatic, electromagnetic wave, right? This light is, so, and its value is 3 into 10 raised to the power 8. It is the constant value, right? It never changes. And for lambda, it is shown in the question, it is 680 nanometer. Convert the nano into a meters. What we need to write, we need to multiply it with 10 to the power minus 9. Right? So just substitute the values and check you get the right answer or not, right? Okay, so what we are getting 3 into 10 raised to the power 8 divided by 680 into 10 raised to the power minus 9. So what answer you get? You get 4.4 into 10 raised to the power 14 hertz, right? This is the right answer. And again, this question contains 3 marks. So the first one is give the correct formula for the frequency, then like substitution, then the velocity one, and then the lambda conversion from nanometer to the meters. Well students, hope this question will be clear. We will do the next question in the next video. Bye bye. Allah Hafiz.